Good morning, grade 10s. This week's lesson is on trigonometry, and specifically what we're looking at today is an introduction to trigonometry and the sine ratio. So what is trigonometry? Trigonometry is the study of the relationship between the sides and the angles of right triangles. So there are three trigonometric ratios that we're going to learn about. We're going to start with sine, okay? And sine is abbreviated SIN. It's not sin, it is sine. And then the following week we'll move on to cosine, abbreviated COS, and then lastly on to tangent, which is abbreviated TAN. Now you're going to need a scientific calculator. If you don't have one with you right now, you're going to pause this video and you're going to go and grab one. Okay, if you've got your cell phone that is able to be turned sideways and become a scientific calculator, again, pause and go and grab that because you're going to want to practice figuring out how to use your calculator while we go through the lesson. Okay. Now, scientific calculators have different modes, and we need to be in degree mode, okay? Not grad and not rad, okay? Now, here's a way to test to see if you're in degree mode. So what you're going to do is you're going to find the tan button, okay? And I've got a picture of a couple of calculators here, one that is a handheld calculator. I just took part of it, and then there's one that's like from a cell phone. Okay. Now up here, I see degree written on the display of the handheld calculator, and I also see it here written with on the like the cell phone one. Okay. So in degree mode, mine shows that it's in degree mode. Now, if you want to test, you can't see a degree written somewhere on there and you're not sure, what we're going to do is we're going to test that it's in degree mode. Okay? So, if you've got the calculator on your cell phone like this one, you're going to punch in 45 and then you're going to punch the tan button. Okay, now there is a tan here, and then there's a tan H, or sometimes a tan with a -1 exponent on it. You want to make sure that you just press the plain tan button. And what it should equal is it should equal 1. Okay, that works for some handheld calculators to do it in that order. Okay, a lot of handheld calculators are in a different order. So you could try that and you should get 1. If you get an error button, then try this. You're going to go tan first. And then you're going to punch in 45. And then you're going to have to punch the equal sign. And what you should get is 1. Okay? Now, if you don't have that, what you need to do is you need to change the mode, okay? And you should find a button that either says mode or degree or even rad or grad. So to change the mode, right? You should be looking for a button that says mode. You should be looking for a button that says degree, or you might even find one that says rad. Whoops, not rand, but rad. Or a rad/degree button. Okay. Now, I see them on this calculator right here. So right there is the degree button. And if you press it, it goes to degree. If you press the second function and that button again, it will scroll from different, it'll go grad, rad, degree kind of thing. It'll scroll across, okay? Now, for the one on the calculator on the cell phone, there's a button here that says rad. If you press that, you'll see it turn to rad up there, and then this will turn to degree or to grad, okay? And then it'll just change from mode to mode, okay? So you're using those buttons. Okay, so you should be in the correct mode. Okay, if you're having trouble with your calculator, you can send me a message and I can try maybe to help you with the calculator. Okay, now always test it with this 10 of 45 is equal to 1. That's an easy way to test that you're in the right mode. If you get a different answer, then you know you're in the wrong mode. Okay, so now going back to trigonometry. Okay. So what is the point of the trigonometry that we're doing? Well, these ratios are used to find things like missing sides and missing angles. Now remember that this only works with a right angle triangle. So remember, in right angle triangles, you got this right angle here that is identified with the box. So that is the right angle. And this right angle is also always 90 degrees. And in order for us to use this, you have to remember that across from the right angle, right, is always the hypotenuse, okay? So remembering that the hypotenuse is always across from the right angle, okay? Maybe I better just, draw that arrow back in, and I'll just highlight that. Okay, so that always going directly across from the right angle, we hit the hypotenuse. Okay. All right, now moving on, there is an acronym or a word that has been made up, right? That's what an acronym is. And it's the letters that help us to use trig. So this acronym is a crazy word. We pronounce it SOHCAHTOA, okay? And you'll notice that there's 3 letters, 3 letters, and 3 letters. Those are the 3 trigonometric ratios. The S stands for sine. And sine, the order that helps us with what sine means is that the sine of an angle is equal to the O for opposite over H for hypotenuse, okay? This little, what looks like an L is actually a bent over a little bit. It is a symbol for angle, okay? So the O is for opposite and the H is for hypotenuse. Those are the sides of the triangle that sine works with. Okay, we will be moving on to cosine or cos. Oops. And then we'll be moving on to tangent, which is TAN, tan, abbreviated. Okay, but today, working with sine, we're dealing with opposite and hypotenuse. So SOH means sine is equal to, sine of an angle is equal to the opposite over the hypotenuse. So opposite and hypotenuse today, okay? So here's our sine ratio. If you take the opposite of side of an angle and its hypotenuse, and you divide them, you get a ratio that is always the same for that angle, okay? Now, we're going to use the sine button on our calculators today, so you need to find the sine button. If we go back up to the 2 calculators that I have up here, we can find sine here, okay? And we can find sine here, okay? So let's go back now and look at being able to figure out which sides are opposite and hypotenuse of an angle, okay? Because it depends on the angle we're talking about as to which one is opposite. The hypotenuse is always the hypotenuse, but the opposite for one angle in a triangle is not the same as the opposite for another angle in the triangle, okay? So this ratio can be used to find the angle between these two sides, the opposite and the hypotenuse. So here we are, we're looking for angle H. Angle H is this corner right here. And if we want to find the angle, we need to be able to use the opposite side and the hypotenuse. Well, you all know that across from the right angle is the hypotenuse. So here's our right angle. So if we go across from that, we find the hypotenuse. Now, angle X, if we go opposite of angle X, that gives us the opposite side. So opposite the right angle is the hypotenuse, and opposite of angle X is this side here, which is the opposite side. Okay? If we go to a different triangle, okay, again, opposite the right angle is still the hypotenuse, but now we're looking at angle Y. And angle Y is down here, this corner. So if we go opposite of angle Y, we're going to this side of the triangle. So now this side is the opposite. This side here is the opposite of Y. Where for angle X, this one was the opposite. Now, if I take the triangle and I just spin it around so that it looks different, okay, we have to be able to always identify the opposite and the hypotenuse. So start with the hypotenuse. There's our right angle. We go across from that, and there's our H. Now we're looking at angle Z here. That's this corner. So if we go opposite of that corner, we can just draw a line directly across from that to the side, and that is the opposite side. So you can see that the side, opposite side, depends on which corner or which angle we're looking at or being identified. Okay, so the SINE button, this one gives the ratio, okay? And that ratio is a fraction, and it can be converted to a decimal. So if we took the opposite and divided it by the hypotenuse, we're going to get a decimal, okay? But the ratio, if say we had angle 30, the opposite and the hypotenuse will always give the same decimal for any angle 30. It will be different than, say, an angle 40, but any angle 40 on any triangle, doesn't matter how big or how small it is. If you take the opposite side and divide it by the hypotenuse, that decimal will be always identical for every angle that is 40 degrees. Okay? So now we have what we also call the inverse of sine. And on our calculators, we're going to find that there is a sine button, but it's got this -1 exponent on it. And that means inverse, okay? I've noticed that some calculators have a sine H, okay? And that means the same thing. We're looking for the inverse, okay? And this sine inverse button is used if we're trying to find the size of the angle, okay? The sine button, if we go back here, it gives a ratio which is either a fraction or a decimal, okay? And on this inverse sine, it gives us the angle. So sine gives us the ratio, and the inverse of sine gives us the angle. Okay, hopefully that's going to make more sense as we go through some examples. All right, now this is where you need to use your calculator. So we want to find the ratios. So that means we're going to use the sine button, okay? And it's going to come out as a decimal. It's not going to give us a fraction. It's going to say, okay, if we have a 30-degree angle and we take the opposite side and we divide it by the hypotenuse, we're going to get a decimal. And I want us to round to 3 decimal places. Okay, so I've got a calculator here I've just bring up. And this one is where I'm going to have to punch in the 30 degrees first. Okay, and then punch in the sine button. Okay, so for some of you, your calculator, you're going to go 30 degrees first, and then you're going to punch in the sine button. Okay, and then some of you are going to have to go sine first, and then 30, and then I think an equals. Okay, so mine I have to go 30 degrees first. So I'm going to punch in 30. Okay, you can see it up here. And then I've got hidden here the trigonometry buttons, and I can see sine right here. So I'm going to punch that, and it gives us an answer which is equal to 0.5. Now I said we wanted to round to 3 decimal places, so we need 2 more places there, and because the calculator didn't give any more than 1 decimal place, we're just going to add zeros to make it 3 decimal places. Okay? Let's try this again with 25 degrees. Okay, so again, some of you are going to have to go 25 first and then sine. And then some are going to have to go sine 25. Okay, so for this one, I got to clear. And I'm going to go 25. And then my trigonometry button is sine, and it gives me, you can see a big, huge, long decimal. Now we're going to round this to 3 decimal places. So I'm seeing 0.4226. 0.4226. Now it continues past that, but I only need to go to 4 places to decide to round. So I'm going to cut it off after 3 decimal places. So I'm going to look at the part that's been cut off. If it's a 5 or higher, in this case, we're going to add 1. So this is going to equal 0.423. Okay, rounded. Okay, let's do another one here, the sine of 78 degrees. So I'm going to clear this, and then I'm going to press 78. And the trigonometry button gives me here, you can see the sine, and it's 0.9781. So 0.9781 continues on, but I'm cutting it off. So I'm only looking at 4 places to decide what my rounded 3 should be. And in this case, that is if it's a 4 or less, we just drop it off. We don't add 1. So the answer here is going to be 0.978. Okay, 3 decimal places rounded for those ratios. So it doesn't matter if I take any 30-degree angle and I take the opposite and I divide it by the hypotenuse, I'm always going to get 0.500. So it would be like the opposite is 2 and the hypotenuse is going to be 4. If the opposite is 4, the hypotenuse is going to be 8. Any of those numbers divided is always going to give us 0.5 on a 30-degree angle. Okay, so here's what that example would look like. So this is what you would get if you had an angle and you divided its opposite side by its hypotenuse. So this is a 30-degree angle, okay? And if we take this side, which is the hypotenuse, across from the right angle, across from the angle that we're talking about, the 30 degrees, is the opposite. If we take this 30-degree angle and we find the sine of that 30-degree angle, which is the opposite, which is 5, divided by the hypotenuse, which is 10. 5 divided by 10 gives us 0.5. So any 30-degree angle, if you take the opposite and you divide it by the hypotenuse, you always get 0.5. You could have a different size triangle. You keep this 30 degrees, but you extend the triangle. So if I were to make this twice as long, keep that 30 degrees, this would now say become 20, and this would become 10. You would have 10, the opposite, divided by 20, and it's still going to give you 0.5. Okay? So it doesn't matter. Any 30-degree angle, if you take the opposite side and you divide it by the hypotenuse, you're always going to get 0.5 as the sine of 30 degrees. Okay? It's a ratio that is the same for any angle that is at 30 degrees. Okay, so now we're going to use this idea to go backwards. Okay? So we're going to find the angle of the ratio. So these are some ratios that have been given. So we're going to find the angle. When you want to find the angle, you use the inverse button. Okay? So now to use the inverse button on your calculator, you're going to have to either use a shift key or a second function key. Okay? And look for one of those, shift or second function key, to find the sine of the inverse, okay, which could be sine -1 or this sine h, okay? And with this, when we're looking for angles, we're going to round to the nearest degree. So ratios, we want 3 decimal places, but degrees, we're going to look for the nearest degree. That means no decimal places. So we're going to find the sine of angle F. What would that angle be if its ratio is 0.2? Okay? So again, it depends on the kind of calculator you have. So for some of you, you're going to have to press, let's maybe give an idea of what you would have to press. So you might have to press the second function or the shift button, and then you press the sine key. And when you do that, these two things give you sine inverse, okay? And then you're going to press the ratio, which is 0.2, okay? And then you're going to press the equals sign, okay? So let me show you what that's going to look like. So now with mine, I push the ratio in first. So some of you will do the ratio first and then the second function and sine. Okay? So I got to clear, and I'm going to push in 0.2. Okay, so you can see we could put 0 on there, but it's not going to change anything. It still has the same value. And now trigonometry. See how I don't have sine -1, so I have to push the second function button, and now this sine -1 shows up. And I press that, and now it gives me 11.5369 something, okay? Now, remember, we're rounding to the nearest degree, so we only have to look at the first decimal place. So this is going to give us, let me do this in a different color. This is going to give us 11.5, and then it's going to repeat on. And I am going to cut it off at the nearest degree. So now, in this case, this is a 5 or higher, so we're going to add 1. And this is then going to round to 12, and the units for this is degrees. That little circle means degrees. Okay? So try it with the next one, right? You're going to find the angle D if the ratio is 0.999. So if you're finding the angle, you need to use the inverse button. So, taking your calculator, clear it. And you're going to need to either press the second function first and then sine and then the decimal, or you're going to push the decimal in first and then the second function and sine, okay? So for me, I'm doing the decimal first, so it's going to be 0.999. There's our decimal. And now we need the second function, so I'm pressing second, and then the inverse of sine, and it gives me 87.437. So this is 87.4. Now remember, I'm cutting it off after one at the whole number. I have to look at this decimal to decide whether we're going to stay the same or add one. In this case, 4 or less means we just stay the same. So this becomes 87 degrees. Okay. The last one, we're going to find the sine of x. Again, go back to our calculator, clear it. So for me, I put the decimal in first, so it's 0.819. I'm going to go to my trigonometry functions. I need to press the second function, inverse of sine, and I get 54.98. Okay, so 54.9. I only have to go to one decimal place because I'm cutting it off to the nearest whole degree. Because that is a 9, which is a 5 or higher, we're going to add 1, and this then becomes 55 degrees, okay? You need to have your units on here. It's not just 12 and 87. It's measured in degrees, so you need to have the angle written there. That's why we're actually need to be in degree mode, okay, on our calculators. If you're not putting your degrees on there, you're going to lose half marks. Okay, so we've been able to find the ratio using the sine button. Whoops. Right? So using our sine button, we figured out how to get the ratio. And then given a ratio, we figured out how to be able to get the degree. Okay, so how's this going to help us in finding angles? Okay, that's what we're going to work on next. Now, before we move to that, I just want to, again, show you what this means, okay? So this is what you would get if you had two sides and you divided its opposite by its hypotenuse to get the ratio, and then you inverse the ratio to get the angle, okay? So if we've got two sides, here's our angle here, right? This is our angle here. If we go opposite of the 90 degrees, we get the hypotenuse. If we go the opposite of our angle, we get the opposite side. And now because sine is opposite over hypotenuse, right? So sine of an angle is the opposite over the hypotenuse. Here, if we have the opposite side being 2 and the hypotenuse being 10, if we take 2 and divide it by 10, what we end up with is 0.2. Add 2 decimal places and we get 0.220. 0.200. So that's the ratio. If we know the ratio, we can use our inverse button, right? So sine -1 of 0.2, and what we end up with is 11.5. Okay, so we've done that already. 0.2 gave us 11.5 and we rounded that to 12. So what we end up seeing, right, is that this is a real situation where these two things are the same, right? We get them being equal. So we can use our calculators or we can actually look at a real life situation. Okay? Okay, moving on to example 3. Now, what is the point of this? The point of knowing this ratio is that what we can do is we can find the missing side using our sine button. So what do we need? We need two pieces of information. We need a side and we need an angle. That's two pieces of information, and what we can do is we can find the third piece of information. Because remember, in this ratio, we've got the sine of some angle, is equal to the opposite over the hypotenuse. So here's our three pieces of information, right? We've got an angle, we've got an opposite side, we've got a hypotenuse. Those are three pieces of information. If we've got two of them, we can find the third one. Any two that we have, we can find the third, okay? So in this first set of examples, we're going to find a missing side, okay? And what we need then, if we're finding the opposite, we need to have the angle and the hypotenuse to find the opposite. Or if we want to find the hypotenuse, we need the opposite and the angle. So let's think about this. Before we start, it's really important that we name the sides of the given triangle so that we know which one is the opposite and which one is the hypotenuse. Now, I haven't really talked about the adjacent yet, right? The adjacent is the other angle, or the other side, the side that is not opposite and not hypotenuse, okay? The other thing that we have to remember is that our questions have units, okay, in their answer. Now remember, units for sides are going to be things like centimeters, millimeters, meters, okay? So what's happening in these examples? We're going to find the opposite side, okay? And these are, in fact, the easiest to find, okay? So this is where we're going to start. So here's our angle, 62. That's this corner right here. And we need to have the opposite and the hypotenuse identified. So go across from the right angle, and 17 is the hypotenuse, okay? Go opposite the 62 angle, and that's our opposite. So x is the opposite side, okay? So our angle is 62, our opposite is x, and our hypotenuse is 17. So notice we're looking for the opposite side. That's the unknown measurement there. So we're going to use the ratio. The sine of an angle, I guess I don't really need that line there. The sine of an angle is equal to the opposite over the hypotenuse. That's the ratio. And all we're going to do is we're going to fill in the three pieces of information that we have here. 62 is the angle, so we're going to replace that with a 62. So we're going to have sine of 62 degrees. We're going to replace the opposite with the x, so that's going to equal x at the top, and the hypotenuse is 17, so we're going to put 17 at the bottom, okay? Now, what we need to do next is we need to figure out what x is. So x has to be all by itself. So how do we get x all by itself? Just think about algebra. If you have x divided by 17, you need to do the opposite. You need to times by 17. Okay? And that's going to get rid of the divide by 17. Now, what else do you have to do? If you multiply one side by 17, you have to multiply the other side by 17. So now what do we have? I'm just going to flip this over. So we've got x is equal to, and then I have the sine of 62 times 17. Again, I don't need this. The sine of 62, sorry, the sine of 62 degrees times 17. So now, what is the sine of 62? That is a ratio. So you're going to use your calculator. Remember, sine, we're just going to look for that 3 decimal ratio. If we're given the angle, we're just going to find the ratio. So go back to your calculator and clear it. And you're going to go, for me again, I punch in the 62 first, and then I go to my trigonometric function and I press sine. And remember, we're going to 3 decimal places. So 0.829, the 2 is going to round up to a 3, so it's going to become 0.83. Is that right? 882 rounds to 883, yeah. And then I'm going to times that by 17. So just take your calculator again and take that number and times it by 17. And what we end up with is 15.01. Now, we want sides to 1 decimal place, ratios to 3 decimal places, angles to no decimal place, but sides to 1 decimal place. So this is going to be 15 point, it's going to round to a 0. So we get 15.10, it's going to blah, blah, blah. We're going to cut it off to 1 decimal place, so this is a 0, so that's going to equal 15.1. And what are our units on this? This case, it happens to be millimeters. Okay, that's our final answer. We've found the missing side. Okay, let's try this again, speed it up a little bit. Okay, here's our angle here, which is 45. So now opposite the right angle is the hypotenuse, opposite the given angle is opposite. So now here's our ratio, right? The sine of an angle is equal to the opposite over the hypotenuse. Substitute in the 3 pieces of information we have. The angle is 45, so we're going to go the sine of 45 degrees is equal to our opposite. If we look here, that's our W, and our hypotenuse is 14.5. So hypotenuse at the bottom is 14.5. Okay, we're trying to get W all by itself. So what do? We need to get rid of the divide by 14.5. So we're going to multiply by 14.5. Same thing on the other side, multiply by 14.5. 14.5 cancels out the 14.5, and we got W all by itself. Now I'm simply going to flip this. So W is going to equal the sine of 45 times 14.5. Whoops. Times 14.5. Okay. Now we're going to use a calculator to find the sine of 45. So clear it. I punch in my 45 first. You might be punching in sine first. Then press the sine button, or sine of 45, and we get 0.701. So that's going to round to 0.707. So this is going to equal 0.707, and that's going to be multiplied by 14.5. So again, just leaving that number in my calculator, I'm going to times that by 14.5, and that's going to equal 10.25. Remember, that continues on, but we're rounding to 1 decimal place for a side. Because this is a 5 or greater, I'm going to add 1, and we end up with 10.3, and in this case, it is meters as our final answer. Okay, so that's finding the opposite side. The next 2 examples are finding the hypotenuse side. Now remember, these questions are designed to be using the opposite and the hypotenuse because sine ratio uses opposite and hypotenuse. So all these questions have opposite and hypotenuse. Okay? So let's look at this. Finding the hypotenuse is a little bit more complicated. Okay? Again, start by identifying the sides. So opposite the right angle is the hypotenuse. Opposite the angle is opposite. Okay, and we're going to substitute this into our formula. So the sine of an angle is equal to the opposite over the hypotenuse. So in this question, the angle is 28 degrees. Okay, so we're going to substitute that in here for the angle. So the sine of 28 degrees is equal to, now what's the opposite? Goes at the top. The opposite of 28 is this 6 centimeters. And the hypotenuse is our y, our unknown. Now we can't have our unknown at the bottom, okay? That's the problem here. So this makes the question a little bit more complicated. So how do we get the y off the bottom? Well, this is a divide by y, so we do the opposite. We're going to multiply by y, okay? Dividing by y and multiplying by y cancels each other out, so that gets the y off the bottom. What else do we have to do then? Multiply this side by y. So now y is at the top, but on the opposite side. Now we're trying to get y all by itself. So what do we need to do? We need to, in fact, get rid of the sine 28. So y is multiplying sine 28, so we need to divide by sine 28. If we divide the left side by sine 28, we're just going to extend the divide line here, and we're going to divide the right side also by sine 28. So now, on the left, sine 28 cancels sine 28. What's left is y. So now look, we've gotten y all by itself. And what do we have on the other side? We have 6 at the top, and we have the sine of 28 degrees at the bottom. Okay? Now, use your calculator, figure out what the sine of 28 degrees is. Okay? So what we're going to end up with is still 6 at the top, but we're going to find out what the decimal is for the sine of 28. Remember, we get it to 3 decimal places. So here's the calculator. I'm going to clear it. We're going to go 28 degrees, and then we're going to use the trigonometry button for sine, and we get our decimal, right? 3 decimal places for that ratio. So 0.4694. It's not going to round up, so it's going to stay 0.469. 0.469. Now all we have to do is take our calculator and divide it by 6 divided by 0.469. So I'm going to clear, and I'm going to start with 6, and I'm going to divide it by 0.469, and that's going to equal 12.79. Now remember, sides were going 1 decimal place, so 12.7 in this case, we look at the 9, it's going to round up to 12.8. So this is going to equal 12.8, and this question has centimeters, so our side is going to be 12.8 centimeters. Okay? Let's do a second example. Identify the sides. Well, here's our angle. Okay, that's this point here. So opposite of our angle is the opposite side. Opposite of the right angle is the hypotenuse. So H is K and O is 9.8. So start with our formula. The sine of our angle is equal to the opposite over the hypotenuse. This angle, so the sine, this angle happens to be 48 degrees. Its opposite side is 9.8, and its hypotenuse is using the letter K. Okay? Now remember, we need to get K off the bottom. So how do we get K off the bottom? Well, we use the opposite of divide by K. So we're going to times by K. That means we have to times the other side by K. K divides by K to get K off the bottom. Now, at the same time, we need to get K all by itself. So we need to get rid of this sine 48. So K is multiplying sine 48, so we're going to do the opposite, which is divide by sine 48. On the other side, we need to do the same thing. We're going to divide by sine 48. Sine 48 on the left divides by sine 48 to be removed. All we have left is K. We've done it. We've got K all by itself. On the right-hand side, we've got 9.8 divided by the sine of 48. Now these are degrees. I should be writing degrees in there. So now we're going to find the sine of 48 so that we know what that ratio is. Use the calculator. 9.8 is going to stay 9.8, but the sine of 48, we use our calculator. Okay, so clear this. And again, for mine, we're doing the degrees first. So 48 goes in, then find our trigonometric function of sine and press that. For some of you, it's going to be sine first and then 48. Now we want 3 decimal places. So 0.7431. So the 3 is the 3rd decimal place. The 1 is the cutoff. So we're going to leave it there at 0.743. Now just simply take the calculator and divide those numbers out. So clear it. 9.8 divided by 0.743. And what do we get? This is going to equal, oops, I missed it, 13.18. Remember, we're going to 1 decimal place for sides, so that 0.1 is going to round up to a 0.2. So this is going to become 13.2. And in this case, it is meters. So meters is our answer. So the length of this side, the hypotenuse side, is 13.2 meters. Okay. So we found the opposite side, we found the hypotenuse. Now we need to be able to also find the missing angle. So if we're looking for the missing angle, and again, we want to do that to the nearest degree, to find angles, we use the inverse button. Now this works when we are given 2 sides. Remember, you have to have 2 pieces of information to figure out what the missing 3rd piece is. Again, we always want to start by naming the sides. Okay? Remember, we're using opposite and hypotenuse. And we need units, and remember our units for degrees in the answer is going to be, right, that symbol. Okay, so here's where we're at. Here's our angle x. So we need to identify the sides. So opposite the right angle is the hypotenuse. Opposite the angle we want to find is the opposite. So hypotenuse is 10, opposite is 7. So use the same ratio. The sine of an angle is equal to the opposite over the hypotenuse. Substitute these 3 pieces of information, x, 7, and 10, into the formula. So the sine of x, we don't know what that is, that's what we're trying to figure out, is equal to the opposite. The opposite is 7, and the hypotenuse is 10. Okay, so now for this, you're simply going to divide. Take your calculator, 7 divided by 10, and we get a number. We get 0.7, right? I know that one off by heart. You may not, but again, here I'll bring the calculator up. 7 divided by 10 equals 0.7. So now we have the sine of x is equal to 0.7. This is where we're using our inverse. Okay, so we're going to use sine -1 of 0.7, okay, or we're going to put 0.7 and then sine -1, depending on which kind of calculator you have, okay, and this one you'll have to also hit the equal sign, okay. So now go to my calculator. We've got 0.7 in there. The trigonometric function, now I'm looking for sine -1. I have to push the second function, okay? So maybe I better put this on here that you need the second function. And then that would mean in here you'd need the second function, okay? So I'm going 0.7 second function sine -1. Let's clear this just so we go through the whole process. So start with 0.7. Then we're going to go second function, sine of -1, and we get 44.4. Now remember, 4 degrees, we want a whole number to the nearest degree. So that's a 4 less, so it's going to stay 44. So this is 44.4, blah, blah, blah. So that's going to round to 44 degrees. That's our final answer. So this angle X here is going to be 44 degrees. Okay, let's do a second example of these. Finding the angle is actually easier. It's just a matter of remembering which button to use. Sine is looking for the ratio. Sine inverse is looking for the angle. Okay. So again, start off with identifying the sides of the triangle. So here's our angle Y. So if we're going opposite of Y, that's our opposite. Opposite of the right angle, that's our hypotenuse. Okay. So the ratio is the sine of the angle is opposite over hypotenuse. Fill in the 3 pieces of information. So sine, our angle is Y, is equal to our opposite is 4 over our hypotenuse, which is 7. Now, if you have the ratio, you're going to turn that into its decimal. So you can just simply take 4 and divide it by 7. Remember, you want it to 3 decimal places. So we're going to clear here. 4 divided by 7 equals 0.5714. So it's going to be 571. So 0.571. Now we're using the inverse button to find the degree. So Y is going to equal, right, the inverse of 0.571. So clearing my calculator. In this case, I'm going to punch in for me the decimal first. So decimal 571. Then I'm going to go to trigonometry, and I need my second function and the inverse of sine, and we get 34.81. Remember, we're rounding to the nearest degree, so this is 34.8. Blah, blah, blah. We're going to cut it off to a whole number for the degree, and Y is going to equal 35 degrees in this case, because we're going to add 1 because it's a 5 or higher. Okay? Okay, now the last type of question is where we have to find all of the missing sides and angles. Okay, so in this case, we've got a missing angle here, we've got a missing angle here, and we've got a missing side there. Now, you have a bunch of things in your toolkit to use. You don't just have to use what we're doing today, the sine ratio. So you can use sine to find a missing angle or a missing side. To find an angle, you need 2 sides, right? 2 sides gives you an angle. To find a side, you need an angle and 1 side to get the missing side, okay? So we have 2 sides so we can get an angle. We don't have 2 angles, so we can't use that one yet, okay? But what else do you have? You have Pythagoras in your toolkit. With Pythagoras, you need 2 sides to find the third side, right? We've got 2 sides. So if you prefer to use Pythagoras, you could use it to find this missing side Z. What else do we have in our toolkit? We have the idea that the sum of the angles is 180 degrees. Well, you need 2 angles to find the third one, okay? We don't have 2 angles, we actually have 1. We have a 90-degree angle, okay? Now that 90-degree angle does not work for the sine ratio, okay? So we can't use that angle for this. So maybe some of you like Pythagoras. So I'm going to go back and review Pythagoras here, right? So we're going to find the missing side. So we're going to find, whoops. Z using Pythag, okay? So remember the formula. a squared plus b squared equals c squared. Now, when we did Pythagoras, remember, opposite of the right angle was side C. So this is going to be C, this is going to be A, this is going to be B. So we're just going to simply substitute those into our equation. So A is 4, so that's going to be 4 squared. B is Z, so that's going to be Z squared. And C is 13, so that's going to equal 13 squared. So now we square our numbers. 4 squared gives us 16 plus Z squared is equal to 13 squared, which gives us 169. Okay. And now we need to get Z all by itself. So what do? We're going to subtract 16 from both sides. And then Z squared is equal to 169. So 160, whoops, clear that. 169 minus 16 equals 153. And now what we're going to do is we're going to take the square root of 53. Now, what is the square root in this calculator? Square root. I haven't tried this. Oh, well, I'll use my other calculator here. Yep, can't find it. Okay, so the square root of 153 gives me, so remember, to find Z, we're going to take the square root of Z squared to give you Z. That means we're take the square root of 153, and that's going to give us 12.36, blah, blah, blah. We want our sides to 1 decimal place, so remember we're cutting off here. That's a 5 or higher, so we're going to add 1, and that means that Z is equal to 12.4, and in this case it's millimeters. Okay, so we found this side to equal 12.4 millimeters. Okay, now what we need to do is we need to find the angles. Now, in case we messed up and 12.4 was not the correct answer, I think it's a good idea to not use that necessarily to solve, but you can, okay? What we need to do is to find either X or Y. Now, if we think about angle Y, 4 is opposite of Y, and 13 is the hypotenuse. So we could use SINE to find Y, because we have the opposite and we have the hypotenuse. So the sine of an angle is equal to the opposite over the hypotenuse. And the angle we're looking for is Y, so sine of Y is equal to, now, opposite of Y is 4, okay? And then opposite of the right angle is the hypotenuse, so the hypotenuse is 13. So putting that into our formula, opposite is going to be 4, hypotenuse is going to be 13. So now, simply take your calculator, clear this, and we're going to go 4 divided by 13. And we get 0.373076. We're going to round that, so it's going to be 308. So this becomes 0.308. Now we're going to use, if we want the angle, we need to use the inverse of sine. So we're going to use sine -1 to find the inverse, okay? So sine -1, let's go back to our calculator. Clear it. And I'm going to punch in my 0.308. and my trigonometry function, press second and then the inverse sine button, and that gives me 17.938. Okay. So y is equal to 17.9 blah, blah, blah. Remember, we're rounding off to a whole degree. So that's going to mean we're going to add 1, and y is equal to 18 degrees. So we've got y now being equal to 18 degrees. So if we have now the missing angle over here to find, the easiest way to do this is to use the sum of the angles. So remember that if we're going to use the sum of the angles, that 180 minus 90, which is the right angle there, minus the other one that we found, minus 18, that's going to give us the third angle. Because remember, all three of these have to add up to 180. So if we start at 180 and we minus the 2 we know, then we're going to end up with the answer of the unknown. Okay, so I'm going to clear this. I'm going to go 180 minus our 90 minus our 18, and that's going to give us the final angle at 72 degrees. Okay, so that means this was what? This was angle X. So X is equal to 72 degrees. So this one is now 72 degrees. We've discovered, right, the answer to the all the missing sides and angles using all of the stuff from our toolkit. Pythagoras, we've used the sine ratio, and we've also used the sum of our angles. Okay? So, onto your worksheet today. It's going to be fairly extensive. It's going to get easier. Next week we're moving on to cosine, and once you practice this, cosine is going to come a lot easier, and then moving on to tangent, and you're going to breeze through that. This may seem difficult in the beginning, but again, come back and re-watch the video examples that are similar to the one you're trying to solve, and work through by adapting what I've done to solve the example questions that match your assignment questions. Good luck and take care.